This is Dr. V. Marie Antoinette Martin, Assistant Professor, Department of Information Technology, St. Joseph's College, Trichy. In this session, we are going to discuss about matrices and list using R programming. Content: Matrix in R programming, how to create a matrix in R, matrix operations in R, what is a list, how to create a list, accessing list elements. An R matrix is a two-dimensional structure that stores data of the same type, such as numbers, characters, or logical values. It is arranged in rows and columns, just like a table or a spreadsheet. Matrices are useful when we need to organize data neatly and perform mathematical or statistical operations on them. We can create a matrix in R using the matrix function. Inside the function, we give the data first, followed by the number of rows and the number of columns we want. By default, R fills the matrix column wise. For example, when we write matrix C of 1, 2, 3, 4, 5, 6, n row equal to 2, n column equal to 3, or will arrange these 6 numbers into 2 rows and 3 columns, filling down each column first. We can also fill a matrix row wise in R. To do this, we use the by row equal to true option inside the matrix function. For example, when we write matrix 1 is to 6, n row equal to 2, by row equal to true, or will take the numbers from 1 to 6 and fill them across the rows first. So the first row gets 1, 2, 3, and the second row gets 4, 5, 6. Matrix addition and subtraction in R are very easy. They work only when both matrices have the same number of rows and columns. To add two matrices, we simply use A plus B. To subtract them, we use A minus B. In both cases, R will perform the operation element by element. Matrix multiplication in R is done using the percentage star percentage operator. This performs true mathematical matrix multiplication, where rows of the first matrix are multiplied with columns of the second matrix. If we want to multiply matrices element by element, we use the star operator. This means each element in matrix A is multiplied with the corresponding element in matrix B. The transpose of a matrix in R is found using the T function. This simply flips the matrix, turning rows into columns and columns into rows. To find the determinant of a matrix, we use the det function. The determinant is a single number that gives important information about the matrix, such as whether it is invertible. To find the inverse of a matrix, we use the solve function. The inverse is a matrix that, when multiplied with the original matrix, gives the identity matrix. A list in R is a very flexible data structure because it can store different types of data in one place. Unlike vectors or matrices, which can hold only one type of data, a list can contain many different types such as numbers, strings, vectors, matrices, data frames, and even other list. So we can think of a list as a container that can hold a mix of different items together. We can create a list in R using the list function. Inside the list, we can store different types of data. For example, in this list, we have a number, a name, and a vector of marks. We write my list equal to list of number equal to 10, comma, name equal to Maria, comma, marks equal to C of 90, 85, 92. This creates a list with three elements, each with its own name. This shows how a list can store mixed data in a single object. We can access elements of a list in R using double brackets. Double brackets give us the actual value stored in the list. For example, my list 1 gives the first element in the list. We can also use the name of the element, like my list name, to directly get the value stored under that name. So double brackets are used when we want to extract the exact object from the list. We can also access list elements in R using the dollar sign operator. When we write my list dollar name, it directly gives us the value stored in the element named name. This method is easy to use when the element has a name. We can also use single brackets to access elements like my list 1, but single brackets return a sublist, not the actual value. So the difference is single brackets give a list while double brackets or the dollar sign give the actual value. We can easily modify elements in a list in OR. For example, if we want to change the value of an existing element, we simply assign a new value to it, writing my list dollar number equal to 20 changes the element named number to 20. We can also add new elements to a list. For instance, my list dollar new item equal to add element creates a new element called new item and stores the text added element in it. So list in OR can be updated or expanded at any time. We can remove elements from a list in OR by assigning null to them. For example, my list dollar number equal to null deletes the element named number from the list. After this, the list will no longer have a number entry. A list in OR can also contain another list inside it. This is called a nested list. For example, when we write nested equal to list of x equal to 1 colon 3 comma y equal to list of a equal to 10 b equal to 20, the element x stores a vector from 1 to 3 and the element y stores another list with two values a and b. Nested lists are useful when we want to organize complex or grouped information. Thank you for your patient listening.